Hey, welcome back guys. You're watching M&S IT Technology. Welcome to CCNE Routing and Switching Tutorials series. Today we are discussing about Spanning Tree Protocol. In this video we are going to discuss about redundancy in a converged network, how Spanning Tree Protocol eliminates layer 2 loops, the Spanning Tree Protocol algorithm and its 3 steps, Rapid Spanning Tree Protocol. What we want. Redundancy at the distribution and call layers. Multiple switches and trunk links. One link or device fails, another takes over. But redundancy gives loops. Switching loops give problems if all the links are active. Broadcast storms. Multiple frame transmission. Inconsistent switch tables. Broadcast storm. As you can see, broadcast storm in below topology. Multiple frame transmissions. You can see multiple frame transmissions in below topology. Loops by mistake. Even if there are no deliberate loops for redundancy, there can be loops set up by mistake. Ether channel, the exception. Multiple connections do not make a loop where ether channel is used. The links are aggregated to act as one link with the combined bandwidth. WLL discuss in next video. Redundancy without loops. There needs to be just one path at a time. Redundant paths must be shut down, but ready to be opened when they are needed. This must be done quickly and automatically. Spanning Tree Protocol does this. What is a spanning tree? A tree, extended star, topology. A tree has no loops. Spanning all devices. All devices are connected. Spanning Tree Protocol. Used by switches to turn a redundant topology into a spanning tree. Disables unwanted links by blocking ports. SDP defined by IEEE 802.1d. Rapid SDP defined by IEEE 802.1w. Switches run STP by default, no configuration needed. Spanning Tree Algorithm. The switches use this algorithm to decide which ports should be shut down. Choose one switch to be root bridge. Choose a root port on each other switch. Choose a designated port on each segment. Close down all other ports. Outline of process. Choose the root bridge. Each switch has a bridge ID, BID, of priority value followed by MAC address. Switches exchange bridge protocol data units, BPDUs, to compare bridge IDs. The switch with the lowest bridge ID becomes the root bridge. Administrator can set the priority to fix the selection. Bridge ID. The bridge ID consists of bridge priority, extended system ID, and MAC address. By default the priority is 32,768. Lowest priority wins. Value 1 to 65,536. Multiples of 4096. Extended system ID identifies VLAN. MAC address used if priority is the same. Better not to rely on MAC address. Choose the root bridge. A switch starts up. It sends out BPDU frames containing the switch bid and the root ID every 2 seconds. At first each switch identifies itself as the root bridge. If a switch receives a BPDU with a lower bid, then it identifies the switch with that bid as root bridge. It passes on this information in its own BPDUs. Eventually all switches agree that the switch with the lowest bid is the root bridge. Select root ports. Every non-root bridge switch selects a root port. This is the port with the lowest cost path to the root bridge. Select designated ports. On every segment, the port with the lowest cost path to the root bridge becomes the designated port. Close down redundant links. Any port that is not a root port or a designated port is put in blocking state. BPDU. The BPDU message is encapsulated in an Ethernet frame. The destination MAC address is 01:80:C2:00:00:00, which is a multicast address for the spanning tree group. Port roles. SDP makes ports. Root ports, forwarding. Designated ports, forwarding. Non-designated ports, shutdown. Port states in traditional STP. Blocking, receives and transmits BPDU frames. Listening, receives and transmits BPDU frames. Learning, receives and transmits BPDU frames. Learns MAC addresses. Forwarding, fully active, forwards user data. Disabled, administratively shut down. Cisco port fast. An access port leading to a workstation or server does not need to go through the STP modes because it will not be closed down. Port fast allows the port to go directly from blocking to forwarding. If a switch is connected later and the port receives a BPDU, then can go to blocking and then through the modes. Verify spanning tree. Show spanning tree. Topology change notification, TCN. After the network converges, the root bridge sends out BPDUs, but the other switches do not normally send BPDUs back. If there is a topology change, a switch sends a special BPDU called the topology change notification, TCN, towards the root bridge. Each switch that receives the TCN sends an acknowledgement and sends a TCN towards the root bridge until the root bridge receives it. The root bridge then sends out BPDUs with the topology change, TC, bit set. If you like our channel, please do like, subscribe and share. Thank you.